Hello everybody, Justin Rogier here today. So today we're going to be solving a triangle congruence problem using a two-column proof. I know what you're thinking. Two-column proof? Oh man, those are terrible. Let me tell you, it's not as easy as you think it is, but it's not the end of the world. It's not too difficult. So here today, we're going to be solving this triangle right here. Or, excuse me, these two triangles. Now remember, even though it looks like one triangle, it's actually two triangles smushed together. So here we're going to be proving that side SE is congruent to side HE. Now, given that angle T is a right angle, and angle S is congruent to angle H. So, what's our first step here? Well, let's mark down our triangle. So, here we have already that angle T is a right triangle. Now we know that because of those little boxes. Now we have angle S is congruent to angle H. So, let's draw a little thing there, and right there, and give it a little tick mark. So this way we know those two are congruent. And that's just for us. We just want to know that they're congruent so that we can refer to this model further when we're writing our two-column proof here. Alright, so now we're trying to prove that side SE is congruent to side HE. And as you can see, I set a two-column proof up right there. The statement and the reasons. So, let's get started, shall we? Alright, so let's start by giving our givens. So, we'll write angle T is a right angle. And we'll also write angle S is congruent to angle H. And the reason we'll state for that, it's our given. Okay, pretty simple, right? So, now, what we're going to do is we're going to go to a little more simplistic thing about proving a triangle congruent. Now, notice, like I said before, that these are actually two triangles smushed together. Now what we're going to do is we'll look at side ET. Now, something simple about this is that the triangles share this side ET, so they both have side ET in it. Now, this brings us to one of our other points, using something you probably know already. Yes, that's it, the reflexive property. So, we see that ET is on this triangle, and we see that ET is also on this triangle. So we can say side ET is congruent to side ET. Yeah, I know, that sounds pretty silly, right? But it's just one more step to proving our proof. And for this, we'll say the reflexive property. Now, that's all you have to say, reflexive property. That is all the proof you need to prove this. Okay, so let's move on. So, now we see that we have angle T right here being bisected by SH. Now, with that being said, we can also say that side ET is bisected by side SH. Because you can clearly see at this right here, the right angles, that means that they're bisected right here to make that right angle, right? So, here's what we'll say for this one. So since we have ET bisecting SH to make those right angles right there, what we can say is that SH is perpendicularly bisected by ET. Don't forget your lines there. Then why can we say that? Well, pretty simple. The definition of a perpendicular bisector. That's right. That's all you have to write. Definition of perpendicular bisector. You just got to know your vocabulary, and it'll get you through this whole thing. So, we're right here now. Definition of perpendicular bisector. Now, these are a few tips that my geometry teacher taught me as well. And they'll save you a whole lot of trouble by going through those math books and looking up those words and saving you a whole amount of time on doing these proofs. Alright, let's move on. So, now, time to get into another simplistic part of this. So, I want you to notice here, this little box right here. Now, what does that indicate? Go ahead, tell me. You got your answer yet? Go ahead, say it out loud. I know your teachers probably, they want you to be quiet during the video, but come on, I want you to say it out loud. What's that? Right angle, right. It's a right angle. That's it. So, now that we have that right angle here and the right angle here, we can make some assumptions. So we could say that since this right angle belongs to this triangle here, SET, we could say that triangle SET is a right triangle, right? So, we'll have triangle SET is a right triangle. And why? Because of our box there. Our little right angle box right there. It measures that it's 90 degrees. So, we have right angle box at angle T. Because right there at angle T, that's where the box lays. And that means that it's 90 degrees, therefore making SET a right triangle. Make sense? Alright. And we can also, just to save us some time, in the same one, we could write triangle HET is a right triangle. Because, look, at angle T again, there's that right angle box on the other side now this time. So, we can write triangle HET is a right triangle. And we could just make that part of that reason as well. That the right angle box at angle T. Alright. So, we're starting to wrap this up now. So here's what we're going to do. We're going to make these triangles congruent. Now, stay with me here. We're almost done. So, what we're going to do is we're going to look at these two triangles and see what makes them congruent. So, we have triangle SET and triangle HET. Now, what have we noticed? Well, we've noticed that this angle is congruent to itself. We've also noticed that this angle is congruent to itself. We've also noticed, using our reflection property, that side ET is congruent to itself. Now, what can we use now? Well, my friends, I think it's time to use some angle side angle. Alright, so we're going to say that triangle SET is congruent to triangle HET. And why? Because of ASA congruence theorem. That's it. ASA congruence theorem. Now, in case you didn't know, which I'm sure you do, but ASA is saying angle side angle. So this triangle's angle side angle is congruent to this triangle's angle side angle. Now, that's pretty simple, right? But, listen, we're not done. Now, I know I tricked you. That's what I'm supposed to do. I'm trying to teach you some math. There's got to be a few tricks thrown your way, right? Now, you prove these triangles congruent, but what's left? What's left is we've got to do our proof. The proving that side SE is congruent to side HE. Congruent, excuse me. So, now, I know you're thinking, what the heck how are we going to do this? I'll tell you, it's another one of those simple things. Another one of those very easy things that's just a definition. You don't even need to know really what it means. Well, actually you kind of do. But it's so simple to write down. So, I'm going to take the camera in my own hands now. So, let's notice that we've made these triangles congruent now. Right? We've made them both congruent to each other. That much we know. So, what we are going to do is notice, using a simple theorem called, now I know you probably didn't hear that, CPCTC. Now, I'm sure you've covered that in your classroom before, but it's time to review it again. CPCTC. Congruent parts of congruent triangles are congruent. Excuse me. So, by using CPCTC, we can concur that parts of congruent triangles are congruent, because that would only make sense. Because if we have a triangle congruent right here and triangle congruent right there, we can say that this side of that triangle is equal to this side of that triangle. Saying like, alright, So I have a marker, right? A marker right here. And say I have another marker in my hand right here. Now, the cap of this marker is congruent to the cap of this marker. Makes sense, right? Because it's a congruent part of the marker. Now, say we take the caps off. The tips are congruent to each other because they're the same marker. Just like our congruence theorem on this triangle. So, now we can conclude that indeed our side SE is congruent to our side HE. Because, why? CPCCC. Or, catch that? Yeah, that guy in that video is pretty awesome, right? Wish I could be like him. Alright, so, finally, we're running out of space here. We'll write it over here. So, side SE is congruent to side HE because of CPCTC. Right, guys? That's what I just said. CPCTC. Congruent parts of congruent triangles are congruent. Because that only makes sense. So here we have side SE is congruent to side HE because of CPCTC. Congruent parts of congruent triangles are indeed congruent. Just like this marker cap of this one is congruent to the marker cap of this one. Why? Because they're exact same thing. That's it. So, now we've solved our proof. We've gave all our reasons. And I believe, my friends, we are done here. So, I hope this answered any questions you have on right triangle proofs. And I'm sure some of these tips and tricks can be applied to almost any triangle you come across. Alright, my friends, you have a fantastic day.